How's everybody doing out there? So for our last chapter, or last section for chapter 4, we're going to be looking at binomial distributions. So these are going to be distributions that have either sort of a yes or no or some kind of positive or negative thing that's going on. So for our binomial experiments, they have to have the following characteristics. So one, it has to have a fixed number of trials. And it always has to be two possible outcomes. So basically success and failure is what we're looking for. And so the probability of success is going to be P. Probability of failure is going to be 1 minus P. For 3, the probability of success is the same for each trial. The trials are independent of each other. And the random variable X describes the number of successes that we're looking at. So first, let's take a look and try to make sure if we can identify when something is binomial or not binomial. So if we look at example 1, a coin is tossed 10 times, let X be the number of heads that occurs. So in this case, our two possibilities are we can either flip heads or flip tails, so that looks good. The probability of success is the same for each one of them, so it's always 50%. The trials are independent, so this would be a nice binomial experiment. All right, so for B, so we've got 5 basketball players attempt a free throw. Let X be the number of free throws that are made. So this one, be careful, because at first glance it looks like it could be binomial, because if we think about they either make the free throw or they don't make the free throw, we think that that's probably what's the determining factor is here. And that would be true if we had a single basketball player shooting each of these different free throws. But the fact that we have 5 different basketball players shooting these free throws, it's possible that their probability of success could be totally different. Like one person's probability of success could be 90%, another person's could be 75, someone's could be 40. And so the fact that we've got different probabilities of success possibly for each individual player makes this one so it's not binomial. Now again, if we changed it so that it was a single player shooting it, then yes, this could be binomial in that case. All right, so for C, a random sample of 250 voters is chosen from a list of 10,000 registered voters. Let X be the number of people who support the incumbent mayor for re-election. And so in this case, we've got, you can either vote for the incumbent or not vote for the incumbent. We've got, our sample size seems pretty reasonable, so this looks like it's a good binomial. All right, perfect. All right, so when we're talking about our notation, so this is going to be the same as we did for our other probability distribution functions. So the only difference is in this case, our probabilities are all based around this idea of success or failure, and instead of other different possible probabilities. So again, we've got our little table like we had before. And so the goal is we want to know how we actually figure out these probabilities of success or failure. So we do have a nice complicated formula here that we will not be using, but again, I can talk a little bit about it, and I'm going to show you how we can actually do this on our calculator. So if we look at the probability of success with our probability distribution function, we've got this n over x in parentheses, which is what's called n choose x. So that's actually another thing for our combinations that we did back in chapter 3. So NCR is exactly what that nx is in this case. And then we're taking our probability of success raised to the x, the number of people that we're interested in, and then our probability of failure, 1 minus p, and then raising it to n minus x. And that gives us the way to calculate the exact probability. Now, luckily for us, there's a nice calculator command that we'll be using instead. And so what we've got is we've got 2 different possibilities for our formula. So we're going to be either using binom PDF. And so with this one, we're trying to find a single value. So PDF means we're trying to find a single value, where binom CDF is standing for cumulative distribution function. So that one starts with 0 and counts up to whatever value that we're interested in. So the one above is counting the probability of a single event occurring. So this is a single event. And so this one's going to be the sum of everything up to whatever that event happens to be, so plus A. And so again, it does always start with the probability of 0. So we will have some instances where we're interested in the other half and we have to tweak it a little bit in order to make it work. But all right, so with that in mind in this command, let's go ahead, fill out our chart that we've got here, and then we're going to answer these different questions as we go along. So a student takes a quiz with 4 multiple choice questions, each with 5 possible answers. First, write the probability distribution function for this problem. So one thing I've got going on in this case, since there's 4 questions, like we should only have 4 boxes, so I've got a little mistake here. So scratch out number 5. So the 5 is going to be related to our probability. So in this case, since there's a 1 in 5 chance of getting the right answer and a 4 in 5 chance of getting the wrong answer, that's where this 5 is going to come in. So our probability of success is going to be like 1 out of 5 or 0.20. Our probability of failure is 4 out of 5 or 0.80. So that's where those are going to come in when it comes time to talking about these different probabilities and stuff. All right, so now how do we figure out what goes in these different charts? So what we're going to do is we're going to use our binomial PDF command 5 times, 1 for 0, 1 for 1, 1 for 2, 1 for 3, and 1 for 4 to figure these out. So if I flip over to the calculator real quick, so to find where our binomial PDF command is, what we're going to do is hit the second button and then the vars button, which takes us to distributions. And so if I look on my list, and you may have to cursor down, depending on what kind of calculator you have, A and B are exactly what I'm looking for in this case. So A is binomial PDF, B is binomial CDF. So if I click on binomial PDF, and so in this case, my number of trials is how many questions we have total. So we have 4 questions, goes first. And then our probability of success goes second, which is our 0.20. And then we want to figure out what's the probability of missing every single question out of 4. So we're going to put our 0 in. And so that gives us 0.4096 is our probability of getting every single question wrong. So if I flip back over, so I'm going to get 0.4096 is going to go there. And so now I want to repeat this, but replacing that last number with a 1, and then a 2, and then a 3, and then finally a 4. So if I just hit second enter, it pulls up the same command, so I can just go in and replace that 0 with a 1. And so the probability of getting 1 question right is exactly the same as the probability of missing all of them, so 0.4096. So now let's do the same thing for 2. So second enter. So this is the probability of getting 2 correct. So 0.1536. All right, so the probability of getting 3 correct. So again, second enter. 0.0256. And then finally, what's the probability of getting a perfect score? So 0.0016. And again, since we're dealing with probabilities here, and these are all the possible probabilities, if we added the probability of 0 plus 1 plus 2 plus 3 plus 4, that should give us 1 exactly. Because again, if we add up all of our probabilities, it should equal 1. All right, so now that we've got our probability distribution function filled out, now it's just like we would normally kind of answer these questions. So if we go through, what's the probability that a student gets exactly 3 correct? So in this case, we're looking at the probability of x equaling 3. So that one is an exact value, so we would just read it off the chart and get 0.0256 for that one. So what's the probability that the student gets at most 3 correct? So in that case, we're looking for 3 or less. So from like an inequality perspective, this is looking like the probability of x is less than or equal to 3. So what that means is we want to add up the probability of 0 plus the probability of 1 plus the probability of 2 plus, the probability of 3 for those. And then we can add those together, so I'll kind of leave that so I don't have to keep going back and forth between the calculators. I'll let you add those guys up on your own so we can figure out the totals. And then after we're done this, I'm going to come back and talk about how we can use the binomial commands and what the commands would look like for these as well. All right, so what's the probability that it gets less than 2 correct? So the probability of x less than 2, so in this case, we don't want to count 2 as part of our correct ones. So we're looking at just the probability of 0 plus the probability of 1 in that case. And again, I'll let you add these up. What's the probability that the student gets at least 2 correct? So in this case, at least is 2 or more. So we're looking at x greater than or equal to 2. So that means we want to take the probability of 2 plus the probability of 3 plus the probability of 4 and add all those together. And again, I'll leave those for you to add. So what's the probability that the student gets more than 3 correct? So more than 3 is a strictly greater than 3. So in this case, there's just 1, so it's just going to be the probability of 4. But if there was a 5th, a 6th, a 7th, we would keep adding until we got to the very top. In this case, our top value is the probability of 4, so it's just the probability that single value occurs. All right, and then finally, what's the probability that a student gets at least 1 correct, but at most 4 correct? So from an inequality perspective, this is going to be 2 different inequalities. So we're looking for 1 less than or equal to x less than or equal to 4. And so since we want to include 1 and 4 in our list, then we're looking at the probability of 1 plus the probability of 2 plus the probability of 3 plus the probability of 4. All right, so this is how we pretty much did this in the last section. So now we want to talk about how I could redo these without kind of drawing the chart ahead of time and just using my binomial PDF and my binomial CDF commands. So for problem B, if we go back, since this is a single value that we're interested in, then using the calculator, we could have just typed this in as binomial PDF, because again, we're interested in a single value. And so since we've got 4 total questions altogether, our probability of success is 0.2, and we're interested in the number 3, then we could just type that in, and we did that earlier, and that's how we actually got that value. So we'd recreate that exact same answer for this one. All right, so all the rest of them are going to add them up for us, because all the rest of them are going to require us to use CDF in this case. And so for the next one, and so with this one, this is the ideal way that binomial CDF works, because it starts with 0 and it counts up to where you want to stop. So for this one, if we're using binomial CDF, then again, we've got 4 questions. Our probability of success is 0.20, and we want to add the whole way up to 3. So I'd want to type it in exactly like that. And again, my final answer is going to be all 4 of those values summed together. So I don't have to do anything special for that one. All right, so for D, on the other hand, so it is set up in the right way that we start with 0, but again, the value that we type on the inside gets included in our probability. And since we don't want to, we want to count 1, but we don't want to go up further, then we're going to have to tweak this a little bit to make sure we stop where we want to stop. So even though our number over here is less than 2, if we put 2 inside the parentheses, sorry, where in the world did I go? Here we go. If we put 2 inside the parentheses, it's going to count the 2. So what we want to do is make sure we stop before we get to that 2. So we're going to get our binom CDF 4, 0.20, but in this case, we want our upper value to be that 1 here. All right, perfect. All right, so now for E and F, so for the ones that are greater than, this one we're going to have to do a little bit of a trick on and use the fact that our probabilities add together. Because unfortunately, what we want to know is we want to know the probability of 2, we want to know the probability of 3, and we want to know the probability of 4. But again, the way our binomial CDF works is it starts with 0 and counts up to a certain number. So we can use the same way we did knots before as a way to answer this. So if I thought of this as a knot problem, then really I'm looking at what's 1 minus the probability of 0 plus the probability of 1. And if I did that, then I would be left with just the probability of 2, probability of 3, probability of 4. So when I'm setting that up as a binomial CDF, I want to think about it the exact same way. So I'm going to do 1 minus binomial CDF. And again, I want to basically get rid of P0 and P1. So I'm going to get 4, 0.2. And then again, I want to add this up to 1. And if I type that in, then it's actually going to give me exactly what I'm looking for, which in this case is P2, P3, and P4 for those. So those are a little bit tricky. So if it's a greater than, we've got to do a little bit of work because we've got to do this minus for those guys. All right, so let's take a look at F. So again, F's kind of tricky because it looks like it just has a single value, but I'm going to think of it as a not one, so that maybe we're doing it the proper way. So again, if this one had P of 5, P of 6, it had more values, it would make more sense. But really what I'm looking at for this one is 1 minus P of 0 plus P of 1 plus P of 2 plus P of 3. And so again, if I set this up, I'm going to do my 1 minus binomial CDF. Again, my 4, 0.2. But in this case, since I want to count up to 3 as what I'm subtracting out, then I want to make sure I end with 3. And again, in this case, that's going to give me that single value of just P of 4. All right. And then finally, for the last one, with this one, when we've got our 2 different inequalities going on at the same time, so this one we're going to have 2 different binomial CDFs. So what we want to do is first add up to whatever that upper number happens to be. So this is just going to be a straight binomial CDF, 4, 0.2, and since I want to add the whole way up to 4, I'm going to get my 4 there. But now what I want to do is subtract the numbers that I don't want. So in this case, I know I want P1, but I don't want P0, or if anything came before it, I didn't want anything that actually came before it. So what I want to do is subtract off all these numbers that aren't going to appear on my list. So again, I don't want to put 1 in here because I do want 1 to count on my list. So I'm going to have to actually drop down by 1 and go to 0. And I want to subtract binomial CDF of 0 off of there. And so again, what I would do is not only recommend going through, adding these up the way we had them up in there, but also go through, type these into the calculator, make sure you're getting the same exact values, whether you add them up using the chart or whether you're using binomial CDF for those. And if you have any questions or you're getting different answers or anything, stop and let me know. So real quick, just let me summarize what we did here with our binomial PDF and CDF. So again, if we're looking at a single number, we're looking at binomial PDF of what that number is exactly. If it's a less than or equal to, then there's nothing to tweak. We just plug in binomial CDF exactly the same way. And since it's equal to, this number is going to be exactly the same number that goes there. Nothing gets tweaked. But if it's strictly a less than, notice that we have to subtract 1 from that number because we don't want to include that number that's on the list. Now, if it's a greater than or equal to, this is where we're going to have to do 1 minus our binomial CDF. And so in this case, since we want to include that number on our list, we don't want to include that number over here because we're going to be subtracting it away. So that's why we do number minus 1. If it's strictly greater than, we don't want to include that number in our probability. So when we do our 1 minus, we're going to keep that number in there because we want to make sure it gets subtracted out. And then finally, if we have our A's and our B's, so our first binomial CDF goes the whole way up to B. Our second one goes to 1 less than A. And that's going to be consistent for all of those. All right, so in the meantime, like I said, make sure you look through that example, make sure you're getting the same answers when you plug them in. Try practice 1 and practice 2 on your own, and then we'll come back in the next video and talk about the mean and the standard deviation for these. All right, good luck.